Hi guys, welcome to this set of videos. These videos are going to follow along with the notes that come out of your textbook from Chapter 8, Section 6. And what we've been doing in this chapter is we've been taking a good long look at rational expressions and rational functions. What we did is we started the chapter by taking a look at how you can simplify by adding, subtracting, multiplying, and dividing rational equations, all right? Rational equations or rational expressions. And we did that by, in the Chapter 8, Section 2, by finding an LCM. We found the LCM, and we made the LCM our common denominator, right? Our least common denominator, and that would allow us to add and subtract rational expressions. We then moved on in sections 3 and 4 to graphing those rational functions and looking at all of the different sort of real unique characteristics that the graphs of rational functions can have. And now we kind of come to the end of the chapter. What we're going to do here in Chapter 8, Section 6 is, again, we're going to pull that idea from Section 2. We're going to bring it over here, that idea of finding an LCM. But now, instead of using the LCM to help us add or subtract rational expressions, what we're going to do is we're going to use that LCM to help us solve rational equations, right? And we'll talk about how that's going to work in just a second, but before I go too far and jump into it, I'm getting a little ahead of myself because I'm really excited about this section. I love what we do here in this section. Let's get some objectives or learning targets to help you focus as you go through this set of notes. These are the things you should be able to do by the time we get to the end of this. You'll need to be able to solve a rational equation, and then we'll take a look at solving rational inequalities. Now, the way you go about solving those is going to be the same idea. It's just with the rational inequalities, there's a couple extra little things you got to watch out for or sort of take note of when you solve those problems. So we'll jump right into this by solving rational equations, and I've got a great example for you right here. Now, this kind of description right here, here's what we're going to do. Like I said, we're going to go back to Chapter 8, Section 2, where we talked about finding an LCM, the least common multiple of our denominators. All right, we're going to pull that here into Section 6. But instead of trying to find a common denominator so I can add and subtract rational expressions, what you'll notice is I have rational equations. There's an equal sign in there, which tells me, all right, I need to solve for the variable, right? We need to isolate the z, in this case z, get it by itself, and figure out what does z need to be equal to, or not equal to. In some cases, these are rational expressions, so we may need to restrict our domain, but whatever, we're trying to solve for z. Okay, the way that we're going to do that is actually what I described to you here. These are really, the way to solve these is we need to get rid. We need to, eliminate those denominators. This division by 28, I want to make that go away. This division by z plus 2, that quantity z plus 2, I want to make that go away. Division by 4, I want to make that go. I need to make those fractions disappear. And the way we're going to make those fractions disappear is by finding the LCM, the least common multiple, and then we're going to multiply everybody by that LCM. I'll multiply this guy by the LCM, multiply this guy by the LCM, multiply this guy by the LCM. And what you'll see is then the denominators drop out. They go away. You'll get cancellation. The denominators are gone. And once the denominators are gone, that'll allow you to solve a much simpler equation. So let's go ahead and take a look at how this works in this first example problem. Again, like I said, what we're going to do is we're going to pull that idea of LCM from Chapter 8, Section 2. So let's go ahead and find the LCM for these guys. All right, so the LCM for 28. All right, well, here's what I know. The LCM of 28 is going to be 4 times 7, 4 times 7, but a 4 is a 2 times 2. So that would be a 2 squared times 7. So this will factor into a 2 squared times 7. Okay, great. Then I have a z plus 2. Well, that quantity, right, that's a quantity z plus 2. There's nothing I can really do to that. It's just a z plus 2. And then 4. And of course, 4 is a 2 squared. Now remember, the way the LCM works, LCM, there it is. The way the LCM works is I'm going to take each factor, right? I need to count each factor. I need to keep each factor, but I need to keep each factor the greatest number of times it appears. And we said back in chapter 8, section 2, that really all that means is just keep each factor with the largest exponent, right? So we're going to keep each factor, but the one we're going to keep is whichever one has the greatest exponent. So I run through this, I have a 2 squared and a 2 squared. Well, that's the exact same thing, so just keep one of them. I'll go ahead and keep that guy, and so I have a 2 squared. Then I can keep going. Let's see, I have a factor of 7. So I need to keep that guy. He only shows up once, so I'll just keep that one. And then I've got this guy, the z plus 2, and I'll need to keep that as well, z plus 2. All right, so we go ahead and multiply that out, right? That's a 4, that's a 7, 4 times 7 is, so I wind up with an LCM of 28z plus 2. Now, real important thing here, all right, you absolutely, you could distribute that 28 through the parentheses, but don't do that. What you're going to want to do is you're going to want to leave things in factored form. And if they're not factored, you're going to want to go, we'll see in a little bit later in exam problems, you're going to want to factor them, because here's what's going to happen. What I'm now going to do is what I said up above. I'm now going to multiply each of these guys by that LCM, right? And that's right, that's okay. Algebraically speaking, that's legal, because because I'm doing it to one person, I do it to everybody, and algebra says, well, as long as you do it for everybody, right? When you show up to class and you've got candy, as long as you got Skittles for everybody, awesome, everybody's happy. It's when you only give Skittles to a couple of people that things don't work out so well. You lose friends that way. So as long as you have enough for everybody, as long as you do it to everybody, algebra says you're good. So we'll just go ahead and multiply everybody by that LCM. So here's what it's going to look like. All right, I'm going to multiply this side of the equation by the LCM. So I will have 28 times z plus 2 multiplied by 9/28 plus 3 over z plus 2 is all equal to 3/4. Algebra says since I multiplied this side by 28 times z plus 2, I have to multiply this side by 28 times z plus 2. There we go. So I multiplied it by both sides. Now, here's what I've got. Please notice that this is 2 terms. 9/28 plus 3 over z plus 2. I will simply distribute through the parentheses, and here's what we get. We have to write kind of small because I gotta squeeze all this out. And again, I'm showing way more. Once you get the hang of this, please don't think that you have to show all of these steps. You don't. You guys are smart. You're Algebra 2 kids. You can there's definitely steps that we can skip here. I will skip in the future. But for now, I'm showing you everything so you can kind of see the way the algebra works. Anyway, here we go. So this guy times 9/28, so I'll have 28 z plus 2 multiplied by 9/28 plus 28 z plus 2 times 3 over z plus 2 is equal to 3/4 times 28 z plus 2. Okay, there we go. All right, so I know it looks big again. You'll definitely be able to skip steps once you get the hang of this. But now we've come to kind of like the big finale. This is why. Why did we find the LCM and multiply everybody by the LCM? Well, here's why. Check this out. That is multiplication right there, right? And because that's multiplication, I'm dividing by 28 and multiplying by 28. So guess what cancels? 28s are gone. And I told you the idea here is to get rid of the denominators. We'll multiply everybody by the LCM to make that happen. This was my LCM. I multiplied this fraction by the LCM, and the denominator canceled with the 28 in the numerator. Awesome. Check this one out, right? I got multiplication right there, which means in the numerator, z plus 2. In the denominator, z plus 2. Yep, you guessed it. Gone. Fantastic. On the other side, check it out right there, multiplication. Now, they're not going to completely cancel, but it's very, very close. 28 divided by 4 leaves you with 7. So the 4 cancels and the 28 will reduce to a 7. So here's what's left. I have the quantity z plus 2 multiplied by 9. Plus, I have 28 multiplied by 3, right? Because the 3, that's all that's left. The z plus 2's canceled each other out. On the other side, right? 4 canceled with the 28 left you with a 7. So I would have 3 times 7, which is 21. 21 times z plus 2. So I have 21 times z plus 2. And please notice, the denominators are gone, right? The denominators are gone. I've gotten rid of those fractions by multiplying everybody by the LCM. So now all I have to do is get those z's together on the same side, isolate them, and solve for z. So let's see how that's going to go. I will need to distribute the 9 through the parentheses. That's going to give me 9z plus 18. 28, right, is that what I got? Yeah, 18. Yeah, so 28 times 3 should be 84, so that'll be plus 84. Let me just grab my calculator real quick and double check to make sure I did that right. 28 times 3, yeah, awesome, 84. Put that right over there, we might need it again. And then also on this side, distribute that 21. So I have 21z, and of course 21 times 2 would be 42. I'm in green now. 21z plus 42. Great, here we go. I need to get those z's on the same side, so it looks like probably the way I'm going to want to do this, I'll subtract the 9z to the other side. So what I would wind up with then is, let's see, 18 plus 84 is 102. So I have 102 is equal to 21z minus 9z, and I still have the plus 42. I'll subtract the 42 to the other side, so I'll have 102 minus 42. Again, I know I'm showing way more steps than you actually need to show. First time through, I want you to see how it goes. 21z minus 9z would be 12z. Slide up here a little bit. We're almost there. All right, 102 minus 42. Again, you can do that on your calculator if you need to. You're going to get 60 equals 12z. Get the z by itself by dividing the 12 to the other side. And of course, 60 divided by 12 is 5. So what I get is that z needs to be equal to 5. So in order to solve this, right, where is it? There, my original problem. In order to solve this original problem, I need z to be 5. Of course, you can go back and check your answer. I absolutely would suggest that you do. In fact, we're going to, because it is possible to get extraneous solutions, so let's check it. If I plug in a 5 here, right, 5 times 2 is 10, so I wind up with 9 28ths plus 3 tenths. 9 28ths plus 3 tenths. Feel free to use your calculator if you need to, or go ahead and find a common denominator in order to add those fractions, but what you would find is 9 28ths plus 3 tenths does come out to be 3/4, and so our answer right there, z equal to 5, checks out. Check. So please make sure that you check your solutions. It is possible to get extraneous solutions, and you'll just want to check your answers, all right? Head on over to the next page of the notes. We'll try a couple more of these. I'll meet you guys there.